Okay, in this video, we're going to be doing Calc AB problem set number 131. The problems in a playlist are in the description below. Let's get started. All right, the base of a solid is a region in quadrant 1 bounded by y equals e to the 3x, x equals 5, and the coordinate axes. For this solid, cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. I'm going to start with a rough graph. It does not need to be perfect. So here's like e to the 3x, basically. Let's put in x equals 5. And then our cross-sections are squares. They're going to be perpendicular to the x-axis. So we're going from 0 to 5. Our cross-sections look like that in the xy plane, right? And it's a square, so the area of a square is side squared. The side in this case is just e to the 3x minus 0. So we're doing the quantity e to the 3x squared dx. So this will give us 0 to 5 of e to the 6x dx, which will give us 1/6 e to the 6x from 0 to 5. When you plug in 5, you get e to the 30. When you plug in 5, you get 0, rather, you get e to the 0, which is 1. So we are going to get 1/6, the quantity e to the 30 minus e to the 0, which is 1. That's the volume. It's huge, but we don't actually need to like numerically find it. So next up, given the graph of g shown above, evaluate the integral from 0 to 8 of 3g prime of x over 2 minus 4 dx. So the first thing I'm going to do is rewrite this so it looks a little cleaner. I'm going to write it as two integrals, and I'm going to pull out the constant multiple. So 3 integral from 0 to 8 g prime of x over 2 dx minus the integral from 0 to 8 of 4 dx. So this first integral, we're going to use u-substitution on. I'm going to let u equal x over 2, which means that 2 du is equal to dx. When x is equal to 8, u is equal to 8 over 2, which is 4. When x is equal to 0, u is equal to 0 over 2, which is also 0. So there's the 3 that we pulled out. There's going to be a 2 from dx, and then 0 to 4, g prime of u du. The second integral you can just think of as a rectangle that has a height of 4 and a base of 8. So that's just going to be minus 32. All right, so integrating g prime of u just gives us g of u. So 3 times 2 is 6. So 6 g of u, we're going from 0 to 4, and then still minus 32. So this will be 6, fundamental theorem, quantity. G of 4 minus g of 0. Here's where the graph comes into play, right? This is the graph of g of x that we are given. So you can find g of 4 and g of 0. So g of 4 is 1, g of 0 is negative 1. That graph is very interesting considering what little we've done with it, but we get 6, quantity 1 minus negative 1 minus 32. So that's going to give us 6 times 2 is 12 minus 32, which is negative 20. All right, let's take a look at the next problem. If f prime is 5x to the 4th minus 6x squared plus 1, and f of 1 is 8, let's try to find f of negative 1. So this, I'm just going to find f of x and then plug in negative 1. That's my game plan. So f of x will be the integral of f prime of x dx, right? So I'm going to do this as an indefinite integral, solve for c, do all that. So we integrate, we get x to the 5th. We get negative 6 over 3 is negative 2x cubed, and then we'll get a plus x, and then we'll also get a plus c. So we need to solve for c. We know that f of 1 is equal to 8. So when we plug in, we get 1 minus 2 plus 1 plus c is equal to 8. So that it means that c is just 8. So we actually know f of x. F of x is x to the 5th minus 2x cubed plus x plus 8. The actual question is, what is f of negative 1? So f of negative 1, just plug in negative 1. We'll get negative 1 to the 5th, which is negative 1. Minus 2 times negative 1 cubed, which is negative 2 times negative 1, and then minus 1, and then plus 8. So negative 1 plus 2 minus 1 plus 8 is 8. So this is kind of interesting because f of 1 is 8 and f of negative 1 is 8. And after I did the problem, I was like, should I have known that ahead of time? I don't really think I should have, but I'm not really sure. I thought it was an interesting result. Anyway, that's actually the entire problem set. I hope this was helpful, and good luck.